Hello and welcome to CoreTalks, CoreAVI's technical podcast series. Today we're taking a look at how integrators can migrate from OpenGL ES to OpenGL SC. Why would they want to do this? What are the current trends in graphics APIs and how can you achieve them? I'm your host, Mary Beth Behrens, and I'm the Director of Marketing here at CoreAVI. I have with me today Neil Stroud, General Manager of Automotive and Embedded here at CoreAVI, and Peter Papadatos, Director of Product Development. Welcome both.
Hey, Mary Beth, great to be here.
Hello, Mary Beth and Neil. Excited to be here and have this conversation with you guys.
Great. Well, we see a move in many markets to safe implementations of graphics solutions. Some examples are primary flight displays in aerospace, instrument clusters in vehicles, applications that previously had a heavy use of OpenGL ES. Now we see those moving toward OpenGL SC. Neil, we'll start with you. Why is this trend happening?
It's a good question. So GLES is obviously used extensively in embedded systems, but increasingly we see the requirement for safe graphics. And you bring up two great examples there, primary flight displays in avionics and instrument clusters in vehicles. And essentially the problem we're trying to solve here is when you show safety critical information to the vehicle user, be that the pilot or the driver, you need to be sure that that information is rendered correctly because somebody's going to make a decision based on that, whether it's the reversing camera for the vehicle or the speed or changing the altitude of the plane. GLES doesn't really have any safety pedigree, whereas GLSC does. And of course, the expectation is we increasingly live in a safer world, and the use of safe graphics across multiple segments, including automotive and industrial automation, transportation, is only set to increase. So we've got to kind of improve that as we go as an industry and help the industry migrate from non-safety graphics capabilities to safe graphic capabilities. Peter, have you got anything to add to that?
Yeah, definitely. I think what you identified is definitely the motivation around OpenGL SC migrating from OpenGL ES. In essence, OpenGL SC is a subset of OpenGL ES with key focus on determinism in terms of memory usage, but more importantly, it's around the ability to certify the platform, in essence, the driver. A key distinction between the ES configuration versus that of the SC configuration is the way that the shaders are created and executed. Within the ES realm, the shader itself is compiled at runtime, where the application identifies the various shader stages, compiles them, links them, binds them, and then executes them to produce the rendered effect within the underlying driver and silicon. This in itself, I would say, is not certifiable because of the complexity of the compiler stage. With the advent of SC, we take the compiler stage outside of the driver and we create a offline pipeline that constructs the shaders off board. These shaders are evaluated for accuracy, vetted in an offline setting. In most cases, the compiler itself is qualified within that tool chain, and then the application itself will load the precompiled shaders at runtime and use them in a safe and more deterministic manner. So I would say the ability to certify the shaders is the key differentiator between SC and ES in terms of functionality.
Okay, so GLES has been around for a while, right? So it's been extensively used in embedded systems for a long time, and we're moving forward to SC. Now, from what I understand, I think there are different flavors of SC as well. So, Peter, where are we coming from, and where are we heading to with OpenGL SC? What does the history look like, and what does the future look like?
Well, I'll start with, I guess, a bit of an overview across the various variances or flavors of OpenGL in general. We've started with OpenGL 1.x, moving towards OpenGL ES 1.x, and correspondingly OpenGL SC 1.x family. All the 1.x variances of the identified standards are based on a fixed function pipeline, which predefines and predictates the manner in which the GPU is going to be used and ultimately bounds the way your visualization or the authoring of your instrument or instrumentation would be produced. The 2.x variant of each of these standards introduce a programmable pipeline, which in essence provides additional flexibility to the application developer where it's not bounded by the fixed function API defined by the 1.x standard.
Okay, thanks. So I think, what I'm hearing is that from an industry perspective, we're kind of at the GLSC 2.0 revision right now. So I think for the purposes of this discussion, let's focus on that and assume you want to migrate from ES to the latest and greatest, which is SC2. So let's dig into the details of that. So what are the challenges for a developer moving from ES? They've got lots of ES experience. They've got systems that they've deployed. They understand ES really, really well, but they want to take a step into this functional safety domain. What do I need to care about? What do I need to do? Have I got the skill set to do that? What do I need to worry about from a development perspective, tools, all those kinds of things? How easy is that migration?
So it's important to understand the variances between SC 2.0 and ES 2.0. From an API perspective, they're very similar. In essence, SC is a subset of ES. In terms of usage and interaction, they're very comparable to each other. There are some slight differences in terms of how memory is allocated and used, but I would say that would be a subtlety in terms of the variances between the two standards. The key element that developers need to be cognizant and skilled at is the way that shaders are processed and developed as part of the application flow. With ES, the shaders are created and executed in line with the driver, whereas with SC, there's an offline element to the shader construction. I would say that that's the key element and the key learning curve for developers.
Okay, that's helpful. I just want to touch on the performance side of things because, again, going back to the developer who's got a good ES understanding and spent lots of time fine tuning their system and bringing out the absolute peak of performance for that given development. There's often a feeling in the industry that if I'm doing safety, I have to take a hit on performance. So how does GLSC compare as an API from a performance perspective with GLES? Is there a tax? Is there a price I have to pay? Or indeed, can I get better performance using GLSC?
So yes, Neil, this is a really interesting concept, performance. Performance is very, everybody's mindful of performance. And there is a stigma that a safety critical platform would in essence be slower. But in this case, I would say the SC standard is faster than the ES, and it's mainly due to the shader element that I outlined a little bit earlier. As I mentioned, with ES, shaders are done, compiled and linked and executed in line with the driver, which adds a degree of overhead from a startup perspective. Whereas with the SC standard, all that heavy lifting is done offline, and the startup of an application in terms of time for pixels visible on the screen is reduced significantly. And in almost all safety critical applications, there is a requirement in terms of the visualization time for a particular format.
So I get safety and performance. Seems like the best of both worlds. Awesome. So I want to go back to the tools side of things. So what do I need as a developer to actually do that migration? Are there special tools I need to go buy, or can I do that in-house? How big is that leap? And what do I need to invest in, or do I have everything that I need already? And it's a fairly simple migration task.
Yes, there is definitely a tool chain aspect to the migration in terms of creating the shader pipelines in an offline setting. So there's a tool chain that includes a compiler in addition to conversions from GLSL to the format in which the compiler desires. So typically there's a number of tools that are linked together that allow you to generate the pipelines in an offline setting and then make them available for your runtime application. So there is some amount of knowledge that needs to be acquired in order to be proficient in terms of developing an SC application. But I would say there's a lot of overlap. It's just when you do it and how it's stitched together.
Okay, no, that helps. Thank you. I just want to go back to something you mentioned. And you and I kind of live this every day, but for those who are not used to talking around safety critical technologies, you talk about an offline compiler. Can you kind of articulate the difference between offline compilation and online compilation? What's the distinction there, and why is it important?
Yeah, so compilers, I would say, are complex in nature. We use compilers not only for graphics, but your CPUs require compilers to convert the human readable code into machine executable binaries. So the compilers are fairly complex, and as a byproduct, are very, very difficult to certify. So this is kind of the caveat required for the SC solution, where this compiler element that generates the binary necessary for the GPU to ingest and generate the visualization that is instructed is done in an offline setting. So typically the compiler is very tightly coupled to the GPU vendor. Compilers are not kind of one of a kind. They are very tightly coupled to there's no generic compiler for all GPUs. The compiler itself is tightly coupled to the GPU itself that you're using and the corresponding driver. There are additional stages that facilitate the compilation of the shader, and typically shaders are written in GLSL language. So GLSL is the language that's typically used to create the shaders, and most compilers ingest a format called SPIR-V. So the application developer would write the shader in GLSL, feed it through a GLSL to SPIR-V converter, and the SPIR-V format would then be ingested by the compiler and produce the binary that is ultimately executed by the driver.
Okay, thank you. Excellent description. Certification, and of course, when we talk about certification, we're talking about safety certification here, as opposed to other certifications that exist for other reasons. And again, you and I live and breathe this every day, and serve multiple markets, each of which have their own certification standards. So as we know, for avionics, it's DO 178C, for automotive, it's ISO 26262, industrials IEC 61508, etc. Does that matter when we're talking about certification of GLSC2 or SC1, come to that? Or can they be certified to any standard, essentially, that there are no restrictions there? Just to kind of get your viewpoint on that.
Yeah, again, I would say the underlying implementation, like the platform per se, from an ES standpoint, would be very, very difficult and challenging to certify because of the compiler element. So I would say, just going out on a limb, I would say it's not certifiable, or it's not cost effective to try to certify that. There are other elements in terms of memory management and determinism that were introduced as part of the OpenGL SC variant, which in essence address the certification overhead between the two. There's a notion of certification and there's a notion of qualification, and there's a distinction. Typically, the runtime elements are deemed to be certified to a particular regulatory standard. The tools, on the other hand, such as the offline compiler, is not certified, but it is qualified, which enable it to reach the necessary objective with not as much stringency. There's an element of test and validation that factors into the qualification of the compiler, which then hence facilitates the SC variant to be leveraged for safety critical applications.
Okay, yeah, that is a good distinction. You mentioned cost effective, and I think in the context of certifying of GL-ES based systems, of course, you can certify pretty much anything if you throw enough time and money at it. But I think as an industry, there's also a perception, which I think it's difficult to argue against, that there's certainly extra things you have to do for safety certification, extra development steps, process steps. So there is definitely a tax for safety critical designs. And of course, we all strive to reduce that tax as much as possible. So it seems, given the fact that you can get performance certification by migrating from ES to GLSC, this seems like another bonus. You're going to get an easier path to safety certification by migrating to GLSC. So that, I mean, you can look at that in terms of, reduced investment that you need to take, better return on investment, or shorter time to market, measure it however you want to measure it. But that seems like another very tangible benefit to the migration as well. Is that true?
Yeah, for sure. I think there's what I'd like to say is the distribution of wealth to some extent shifts between OpenGL ES and OpenGL SC. We talked about, and we're mentioning it a lot because it is in essence the thrust of enabling the GPU to do its thing. The shader itself is the programs that stimulate the GPU to do its magic. Within the ES realm, this shader generation is resides within the driver layer. And like I mentioned earlier, certifying this element within the driver would be extremely costly and not cost effective in terms of the sustainability of such a model. SC takes this compiler stage outside of the driver and puts it into an offline domain, but by doing so, it adds a degree of burden on the application developer to create the artifacts that to some extent demonstrate that the shader is conformant to the standard. So there are some steps that the application developer needs to perform, making sure that the GLSL code that was created with requirements and corresponding traceability, that indeed the GLSL code does map to the binary that's produced by the compiler. So there is some amount of overhead that's and responsibility levied on the application. And this is where, organizations like CoreAVI that really understand the end-to-end system in terms of the responsibilities that the application has, the responsibilities that the driver has, and then onward to the hardware. We can definitely provide assistance with respect to the needed steps and the optimal path in achieving the certification of the shaders.
Thank you. And that's a beautiful segue into the CoreAVI offerings. Of course, the reason we're here today is not only to talk to everyone around the migration as you think about your safety critical designs and how you get there, but of course, the role that CoreAVI has to play in that migration. And of course, we do have a role to play. We've been doing this for a long time. We've got world-class products that will help you migrate and, of course, deploy into real-world applications. So in the product portfolio today, we have libraries that support both GL SC1 and SC2. And back to Peter's point earlier on about different GPUs, have different performance points, and each one's very individual. We, of course, as a company, support multiple GPU offerings from the semiconductor vendors, so it gives you, port of choice as far as the hardware you want to choose, and then the associated both safety certification standard that you want to go after, and also if you want to do GLSC1, GLSC2. So I would encourage you to reach out to us to get more information on that. I also wanted to take a moment to kind of precede the next podcast in this series when Peter and I are going to get together again and talk about Vulkan, because the OpenGL SC1 and 2 offerings that we have actually are libraries that sit on top of Vulkan SC. Vulkan SC, of course, is an emerging API as well that's taking the industry by storm. And we want to talk about the migration from commercial Vulkan to Vulkan SC and how this all comes together. So I think bear that in mind. Tune in next time for that. I'm going to hand back to Mary Beth to wrap up.
Okay, thanks so much everyone for this great information, and I'd like to thank our guests, Neil and Peter, today, and we look forward to bringing you more information in the next podcast episode in our series. We look forward to connecting with you all again soon. Thanks for listening today.
Good day.
Thanks, everyone.